Every once in a while, a car may develop an unusual noise or vibration, and it drives the owner right up the wall. Naturally, the owner wants it eliminated. So it's up to the service people to find out exactly what the problem is, track down the source, and take care of it. This is why it's very important for the customer and the mechanic to witness the offending vibration at the same time and identify it as the one which is bothering the customer. The key to solving these problems is to go for a ride with the customer. And have him show you exactly what vibrates and at what speeds. After the customer leaves, hook up a portable tachometer and feed the leads in so you can see the tach inside the car. Take the car for a diagnostic road test. The proper diagnosis of noise and vibration complaints is more dependent on complete, thorough road testing than any other service problem. Pick a smooth stretch of road so you can run the car faster than the speed at which the vibration occurs. Diagnosing vibration problems is not as difficult as you might think if you follow a pattern. Be sure your test includes constant speed, neutral coast down, and accelerating conditions. With the transmission in drive, accelerate rapidly. This is to see if the vibration is more pronounced while accelerating through the problem engine speed than during normal driving. If it is, the problem is torque sensitive and could be caused by power plant bending, propeller shaft angle, or a bound-up exhaust system. If nothing shows up, the next step is to conduct a neutral coast down test. First, accelerate until you're running a few miles an hour faster than the speed where the vibration showed up. A word of caution. On cars equipped with automatic speed control, make sure it's off. Take your foot off the gas. Move the transmission lever from drive to neutral. If the vibration or sound showed up in drive while maintaining road speed but disappears when coasting in neutral, the problem is in the engine or related accessories. On the other hand, if the vibration showed up while coasting down in neutral, you can be pretty sure the problem is in the transmission output shaft, prop shaft, axle, wheels, or tires. You've ruled out the engine and related accessories. That means you can concentrate on the chassis. Let's take wheels and tires first. Lateral or radial runout seldom cause problems unless it's so excessive that it can be detected by eyeballing the tire while it's rotating. Be sure and check the lug nuts for proper torque. Next, check for out-of-balance tire and wheel assemblies. Balance each assembly on the car. One way to isolate a problem is to switch tires and wheels. The simplest way to do this is to substitute a set from a similar model car that doesn't have a vibration problem and take the car for another test drive to see if the problem's been eliminated. Incidentally, an out-of-balance wheel cover can cause a vibration or shake problem. This is more apt to occur with heavy cast-type accessory covers than with the lighter standard type. Here are a couple of easy things to check. Make sure the height of the front suspension is correct. Make sure the gas tank is full, or you've compensated for the weight of a full tank of gas with sandbags or whatever. One of the most obvious things to check is the wheelbase on both sides of the car. Measure the distance between the center of the front spindle and the center of rear axle. If the measurement isn't the same on both sides of the car, it could be a broken spring or a broken center bolt. This can cause shifting, and the rear wheels won't track true. Another logical place to look for vibration problems is on the prop shaft. Clean it up first. Some people get an undercoating gun in their hands and get carried away. They spray everything in sight, including the prop shaft. Another thing to try is the prop shaft balance test. Before you begin, remove the rear wheels and put all the lug nuts back on to keep the brake drum from coming off and to maintain balance. Make sure none of the prop shaft balance weights are missing. The prop shaft tube isn't bent or dented. The cross and rollers are centered in the yoke. The universal joints aren't worn. And the pinion flange bolts are torqued tight and even. A car is usually more sensitive to prop shaft unbalance at the rear of the shaft. So, mark the rear in 4 equal parts with a piece of chalk and number them 1 through 4. Next, put this type hose clamp on the prop shaft and position the screw at the number 1 position, then tighten it down. Start the engine and run it up to the RPM range where you notice the vibration on the road test. Listen for a change in sound or a difference in vibration level. If you didn't notice a difference, move the clamp to the number 2 position and run the test again. Do the same thing in the 3rd and 4th position. Let's say the vibration is at its worst when the clamp was in the number 4 position and vibrated the least when the clamp was in the number 2 position. Move the clamp to the number 2 position. If an unbalanced condition still exists, add another clamp at the best position. If the combined weight of the 2 clamp bolts cause an unbalance, rotate the clamps apart about a ½ inch and run another test. Continue to rotate the clamps equally in small increments until the balance is best. Now, suppose your road test showed that the problem is torque sensitive. Check the exhaust system for a bound-up condition. And the power plant bending damper on the transmission to make sure it's free. Next, check the angle of the prop shaft. Clean up the prop shaft. For this test, the car has to be level with the weight on the wheels. Don't use a hoist that will change the angle of the pinion nose. Turn the prop shaft so the cross and roller bushings on the transmission yokes and axle are facing straight down. The magnet on the tool has to have a clean surface to adhere to, so make sure the bushing surface is clean. This is the contact shoe. Make sure the front and rear tabs contact the bottom of the prop shaft when you begin to make a measurement. Also, make sure you don't have any strain on the magnet or the measuring arm. If the rear joint angle is off, you can add shims to take up the difference. Put shims between the spring and the spring seat. A thing to remember, the thick edge of the wedge goes towards the front of the car if you want to reduce the angle, and the other way around if you want to increase the angle. A word of caution, don't shim too much. If you have more than 1/4 inch thickness at the center of the shim, look for other problems. See the reference book for details. After correcting the prop shaft angle, take the car for a test drive to see if you've corrected the problem. If the problem still shows up, stop the vehicle and conduct a neutral engine run-up test. Put the transmission in neutral and run the engine up to the RPM where you noticed a vibration during the test drive. If you can feel the vibration or hear the noise, you've boiled it down to the engine, accessories, or drive belts. Check the pulleys for excessive run-out or wobble. Check belt tension, condition, and bracket attaching bolts. It may be necessary to remove the belts one by one or in pairs to isolate the source of the problem. Well, we've run out of time. So far, we've covered some of the basics. The reference book for this session gets into sounds and vibrations a little deeper. Remember, before you begin to diagnose a problem, find out what the problem is. Talk to the owner and take the car out for a test drive. Use a tachometer to get an accurate record of when a noise or vibration is taking place. Develop a logical sequence for diagnosing and isolating sound and vibration problems. Do it right and listen to your problems disappear.